हम्म, मैं खींचू ना पागलपन की फोटो फैट मैं खींची अपने आईफोन से am I live or not? Mhm. Why my live stream is not visible? Switch account. Mhm. Live is it is visible that I am live, but 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 where is it? Okay, am I audible? Am I audible? Uh, okay, we are good to go then. Yes. So let's start today's stream. And sorry for not having the streams from past 3 to 4 days. I know it's a long gap, but I was busy on my own stuffs, own work. But now we will be continuing the this thing again. We were on C programming, and we have completed arrays, characters, working with strings and loops and all. And the thing that we will, जल्दी आ गया, sleepy dev here. No. Uh, are you new to the stream? Sleepy Dev here. Are you new to the stream? Okay, so sorry for the 3 days delay. Uh, I was doing my own work and now I will be continuing the stream again. And today our topic is pointers in C, and we'll see how pointers will be helpful for us in cybersecurity too. So, without any further delays, let me adjust the camera, then we will start. Mm, The thing is, I also forgot the username that that used to comment on my stream. So, jaldi aa gaya. I don't know who is he or she. So let's start our topic. Okay, and today our goal is to finish pointers. And yes, so character strings. This we have done already, or we have to cover something. I think character strings are not completed. Mm, character operations. Okay. Last time we have created that password manager in C programming, I guess. Let me just redirect to the directory first. CD desktop, uh, work, C programs, okay, ls, okay, mkdir, pointers. I've also changed the theme today. Okay, so CD pointers, ls, okay. So now we should be starting with our new unit, that is pointers. I don't know whether I have completed that last part or not. If it is not completed, I will be completing that at the end. Okay. So we should be starting from pointers today. Okay. We are okay. So unit 11 pointers, and in this chapter you examine one of the most sophisticated feature of the C programming language, pointers. And before starting, I'm already telling you before starting that it is very important unit in respect to C programming, and also when you talk about the usage of C programming in cybersecurity. So I guess my sound is all right. Everything is working fine. Okay. Okay. Everything is working fine. So, okay, let's start. In fact, the power and flexibility that C provides in dealing with pointers serve to set it apart from many other programming languages. Okay, so pointers enable you to effectively represent complex data structures. Okay, represent complex data structures to change value passed as arguments to function to work with memory. Okay, so we can change the value of the argument that has been passed, and we will be working with the memory that has been allocated dynamically. See chapter 17, miscellaneous and advanced features. Okay, so and to more concisely and efficiently deal with arrays. Okay, so what we are doing with pointers, so pointers are just advanced feature of C programming. It's quite complex, but what we can do, we can deal with complex data structures. We can change the value that is passed by an argument, and also we can work with memory allocation, dynamic memory allocation and static memory allocation, if you have ever heard about. So to understand the way in which pointers operate, it is first necessary to understand the concept of indirection. Okay, so you are familiar with this concept from the everyday life. For example, suppose you need to buy a new ink cartridge for your printer. In this company that you work for, all purchase are handled by the purchasing department, so you can call Jim in purchasing and ask him to order the new cartridge for you. Jim in turn calls the local supply store to order the cartridge. This approach to obtain your new cartridge is actually an indirect one, because you are not ordering. Okay, so we are not ordering cartridge, the ink cartridge directly from the local store. Instead, what we are doing, we are contacting the purchasing department or the finance department to order this cartridge. So we are indirectly ordering. Okay, so this same notion of indirection applies to the way pointers work in C. Okay, a pointer proves an indirect means of accessing the value of a particular data item, and just as there are reasons why it makes sense to go through the purchasing department to order new cartridges, you don't have to know which particular store the cartridges are being ordered from. For example, uh, so are there there are good reasons why at times it makes sense to use pointers. So we'll be seeing that later, how pointers are actually used. So there's a definition of pointer, but what we got from this stanza is that pointer will be used in order to access something indirectly. Okay, so wait a minute. Shit. Mm, no problem. So defining a pointer variable. So, but enough talk. It's time to see how pointers actually work. Suppose you define a variable called count as well, as follows. So you can define another variable called int pointer that can be used to enable you to indirectly access the value of count by the declaration. Okay, so int count. So they have declared a variable count that is an integer, and they have assigned the value to 10. Now what they are doing, you can define another variable called int pointers, so that can be enable you to indirectly access the value of the count by a declaration int star int pointer. Okay, so the asterisk, so this is the important thing, asterisk. So asterisk defined to C system that variables int pointer is of type pointer to int. Okay, so after defining the type of data it has, that is it is int, but it is also defining that it is a pointer, it is a type of pointer to int. So this means that int pointer is used in the program to indirectly access the value of one or more integer values. So what we are doing with by declaring this int pointers, we are trying to access the values that are used before. One or more integers can be possible, but this is how pointers work. Okay, so so you have seen how the and operator was used in scanf calls. Okay, so similar way you can see, but and that in the scanf function we use and operator to denote a particular kind of variable. So scanf calls of a previous program, this unary operator known as the address operator, this is known as the address operator, is used to make a pointer to an object in C. So if x is a variable, okay, so scanf calls of the let me read it again. You have seen how this and operator or was used in the scanf calls of previous program. Okay, so this urinary operator known as address operator is used to make a pointer to an object. Okay, okay, so it is pointing to a particular object, that is a particular kind of variable that is stored in C that we have declared. So if x is a variable of a particular type, the expression and x is a pointer to that variable. Okay, x can be of any type because at the starting of the program, after writing the header file and beginning of the function or naming the program, we are declaring some kind of values, and on declaration we also declare the data type, what actually x is. It can be int, it can be char, and when we are doing the scanf thing, we use and operator, and it is used because we need to point at a particular object in C. So and x is a pointer to that variable, it is a pointer to this particular variable x. So the expression and x can be assigned to any pointer value variable if desired, that has been declared to be a pointer to the same type as x. Okay, let's read it again. The expression and x can be assigned to any. Okay, so this and x can be assigned to any pointer variable if desired, that has been declared to a pointer to the same type as x. So okay, so what you can do, you can use this pointer variable like this, and you can just indirectly indirectly assign and x and the type of x both simultaneously. So therefore, with the definition of count and int pointer as given, you can write a statement such as int pointer is equals to and count. So this is a way of pointer, you can say pointer variable, or it is pointing at a particular, it is pointing a particular variable. So to set up the indirect reference between int pointer and count, the address operator has the effect of assigning the variable. So this is used to assign the value to a particular variable as seen in the previous programs, and this is how it will be working now in the pointers. So the address operator has the effect of assigning the variable to int pointer, not the value of the count. So it is only assigning the the variable count, not its value. So but a pointer to a variable count. Okay, so the link has been made between int pointer count and is conceptualized in figure 11.1. The direct line illustrates the idea that int pointer does not directly contain the value of count, but a pointer to the variable count. Okay, so this is int, so it is directly accessing a particular address node, you can say, of count of particular variable, but directly not accessing the value of the count, but a pointer to the variable of variable count. Okay, so it is written here that does not directly contain the value of count, but a pointer, it contains a pointer to the variable count. This is the pointer, and it is just directly linked to this variable count. So to reference the contents of count through the pointer variable int pointer, you use the indirection operator, which is the asterisk. Okay, so if x is defined as type int, the statement x is equals to, okay, x is defined as type int, like we have defined count, and we have done that x is equals to pointer int pointer assigns the value that it is indirectly referred through int pointer to the variable x. Okay, because int pointer was previously set pointing to the count, this statement has the effect of assigning the value contained in the variable count, which is 10, to the variable x. Okay, so if you don't want to directly access the the value of the count, directly assigning it to x, what you can do, we have already defined that int pointer is a pointer variable to this count, and what we want to store this value of the count in x. So what you can do, you can just directly define a pointer variable here to x, and it will be directly assigning the value of the variable count, which is 10, to the variable x. So the previous statement have been incorporated in the program 11.1, which illustrate the two fundamental pointer operators, the address operator and the indirection operator, that is asterisk. So address and the indirection operator, that is asterisk, two operators that we will be dealing. So this is the program. Let's build a program here. Micro what we can say, pointer 1.c. Okay, so firstly, including the header file, include stdio.h, and what we'll be doing, writing the main function int main void starting the program. Now what we'll be doing, firstly we'll be defining a simple variable, that is int count, and we'll be assigning the variable to 10. Okay, and we are also taking one more variable which is int, that is x. So okay, now what we are doing, now we will be taking a pointer in when we want to access this count variable, not directly the value but the variable. So we'll be using x asterisk int pointer. Okay, nice, working good. And now what we'll be doing, we'll be assigning this int pointer first to the variable that is count. So for assigning, we need to use the assignment operator, which is and count done. And what we need to do, we need to set, the fetch the value of count variable that is assigned to it to and put it to x. So for that, x is equals to pointer, that is the, you can say, the address pointer, int pointer. Okay, now we need the value of x. So printf uh, count is equal, we need to see the both the values. Okay, so count is equals to percent %i and x is equals to percent %i. And how do it know the values? So firstly, what we'll be doing, beginning the new line character, it comma, and now we'll be assigning the values. Firstly the count, then x. So we'll be seeing that how this pointers will be working. Return 0 and done. Control S, no errors. Okay, so let's compile this first, gcc pointer, and we'll be saving the output to pointer 1. Hit enter. Okay, so this program should be working fine now. So since we have, so both the values should be now 10, I guess. So count is 10, x is 10. So this is how you can, just directly assign the value to a particular variable by using a pointer. So x should be 10 and count is also 10. Code working fine. What we have done, we have taken two variables, count and x. We need to assign the value of count, fetch the value from the count and assign it to x. So what we are doing, we are using a pointer variable. We are just, firstly we are denoting this pointer variable to this particular variable. Okay, so count, but it is not, directly accessing the value. For accessing the value, you need to assign the operator, assign this variable, this pointer, that is int pointer, which is, addressing at particular node, that is count. Dakshish is in. Hi brother. So this is how pointers work. So let's move forward. So the variables count and x are declared to be an integer variables in the normal fashion. Okay. On the next line, the variable int pointer is declared of a type pointer to int. It is not int, it is pointer to int. That it can be said as which is pointing to a particular integer or integer variable. So note that two lines of declaration could have been bombed into the single line like this. Yes, it can be possible. So next, the address operator is applied. Address operator, okay, so it's x asterisk, so is applied to the variable count. This has the effect of creating a pointer to this variable, which is then assigned by the program to the variable int pointer. Execution of the next statement in the program, x is equals to this, proceed as follow. The indirection operator tells the C system to treat the variable int pointer as containing a pointer to another data. You bro really see Indians using Vim and Vim. It's not Vim, brother. Yes, it's rare that Indians using Vim. It's not Vim. It's micro. Okay. So where were we? Okay, so end pointer, we have seen the variable. Okay, done. So you should realize that program 11.1 is a manufactured example of the use of pointers and does not show a practical use for them in the program. Okay, so we are just, this program is for conceptual work. If you want to assign the variable, we can assign it directly. So next program should be like, what is the work of the pointer, how it is useful, because this, the main motive of the program was to, fetch the value from the count and assign it to x. By the UI, it seemed like it is Vim. No, it's not Vim. It's micro. Linux based. The you can say the UI is a bit similar to Vim. Vim is, yeah, very hectic to use. You can say skill issue, but a lot you'd have to learn a separate commands, WQ and all for that. Uh, Micro is useful. You should just control S and control Q. Control S for save, control Q for exiting. Simple. You can do a lot, but this is basic. So we have seen program 11.1. Now we will be seeing this 11.2 program. Let's just exit this first, and micro p2. Let's write p2.c pointers 2.c, enter. So now we'll be again include, you can say it's a choice, include stdio dot. No, on my stream I got a response, with many response, that why you are not using Vim. I say it's, I don't know how to use. Although I know how to use Vim, but it's bit hectic according to me. Point of view can be differ, but they just make fun by that I am not using Vim. No problem. Void. Okay. So now what we are doing, let me just further example of pointer. So they have some interesting point properties of pointer variable. Here's a pointer. They have not defined anything, not okay, no problem. What they are doing, so they are taking a character C, okay, assigning the value Q to it. Okay, we will be using quoting because we are defining a character. Char, okay, we are taking another pointer variable, you can say, that is char pointer, uh, in direction sign. Okay, we are denoting the value here only. Now what we are doing, let's do this first. Since it is a character C, assigning, and what we can use a capital U to assign this. Nice. Semicolon, or what we can do, we are defining another pointer, so we can directly just write char p, okay, work, and this is equals to char point, since it is a pointer. So we are assigning the C variable na, so for assigning that user assignment operator and C, value of C. Okay, done. So now what we are doing here, what we are printing, so print, so okay, they are printing this value C char pointer. Okay, printing both the values. Hello, lens of nature. Hello, brother. Welcome to the stream. C is equals to assigning another variable. Character point is pointer. We have changed the value of character pointer. Okay, no problem. But we have seen something here that when you are assigning like this, you have done a similar thing here. Okay. Got it. I got it. Because we are using na here we have साइबरसेक पढ़ने आया था पॉइंटर्स का ज्ञान 19th टाइम ले रहा हूँ ऐसे वीडियो से। कोई बात नहीं भाई, कोई बात नहीं। अगर साइबर सिक्योरिटी सही में पढ़ने आए हो तो, अगर साइबर सिक्योरिटी में सही में तुम्हें कुछ नॉलेज भी है, आई एम अज्यूमिंग कि नहीं होगी। अगर तुम अगर ये लाइन लिख रहे हो तो शायद नहीं होगी। कोई बात नहीं, कमेंट डिलीट हो गया तो कोई दिक्कत नहीं है। हेलो ब्रो, हु आर यू? पर भाई साइबर सिक्योरिटी, इफ़ यू हैव एनी नॉलेज ऑफ साइबर सिक्योरिटी, यू शुड नो हाउ पॉइंटर्स आर यूजफुल when you will be doing memory exploitation and binary exploitation, when you are messing up with the machines in the bootloader. I know I am using heavy, कई बार यूज़ करने पड़ते हैं ऐसे heavy words, लोग तुम्हें पागल समझते हैं ना, कई बार तुम पॉइंटर्स पढ़ा रहे हो। सो जब तुम बफर ओवरफ्लो पढ़ोगे, बफर एक्सप्लॉइटेशन पढ़ोगे, मेमोरी एक्सप्लॉइटेशन पढ़ोगे, है ना, नो प्रॉब्लम यार, कोई दिक्कत नहीं है, नेवर माइंड। उस टाइम जब मैं पॉइंटर्स बता रहा हूँ तो ये एरर आता है कि भाई पॉइंटर्स क्या होता है, ये कैसे काम कर रहा है। और जब मेमोरी एक्सप्लॉइटेशन करोगे ना, और जब तुम इंटरनल सी फाइल्स होती हैं विंडोज़ की या किसी भी सिस्टम्स की, क्योंकि सी फंडामेंटल लैंग्वेज है यार किसी भी ऑपरेटिंग सिस्टम की। सो जब तुम्हें कोई इंटरनल फाइल मिलेगी किसी सिस्टम में और तुम्हें बोला जाएगा कि इस सिस्टम को एक्सप्लॉइट करना है, और खास करके लोकेशन को एक्सप्लॉइट करना है, और वहाँ पे पॉइंटर्स आएगा, तो फिर दिमाग घूमेगा कि पॉइंटर्स क्या होता है। Sub to you, sir. What are you studying? Inter, inter. What are you studying? Inter. No, no. Pass out. Sorry, sub to you, sir. Yeah, I know buffer overflow. Nice. If you know buffer overflow. So no problem. Let's get back to our work. Okay, so we have seen that wherever we are here, if you just after writing this, ignoring all this, and after writing this int pointer is equals to and count, and you would write like printf int pointer. Let's do this now. Let's do this. Control sq. Oh, nice. Control sq. Let's go to the previous program and do that thing. Pointer pointer 1c, और एक काम करते हैं इस बार, डायरेक्टली इन पॉइंटर करते हैं, है ना. इसको फेड आउट कर देते हैं थोड़ी देर के लिए. ओके, सो इन पॉइंटर को मैंने एंड काउंट असाइन कर दिया. नाउ विल बी राइटिंग प्रिंट एफ. एरर दिखाएगा मोस्ट प्रोबेबली. प्रिंट एफ इंटीजर्स है परसेंट आई, हमें लेना होगा यहाँ पे इन पॉइंटर. सो इंट, आई थिंक यहाँ पे वेरिएबल का एरर दिखाया क्योंकि इन पॉइंटर एज वेरिएबल डिफाइंड नहीं है. पर लेट्स सी. इन पॉइंटर रिटर्न ज़ीरो भी देना होगा क्या मेरे को? आई थिंक एक्सपेक्ट नहीं है, पर स्टिल दे देते हैं. चलो, कंट्रोल एस. आ गया प्रॉब्लम. मुझे लग रहा था क्योंकि एक्सपेक्ट्स टाइप इंटीजर. हाँ वही ना, क्योंकि program knows that this pointer int pointer is a int, but this int pointer as a variable is not an integer. So वही प्रॉब्लम आ गया. बट अगर मैं करूँ कि एक काम और करते हैं, अगर मैं यहाँ पे int डिफाइन कर दूँ कि int, अब क्या होगा? कंट्रोल एस. सो यहाँ एरर आएगा कि प्रीवियस डिक्लेरेशन ऑफ int पॉइंटर विद int, और यहाँ पे हम डिक्लेरेशन एज अ स्टैंडर्ड वेरिएबल कर रहे हैं. सो डायरेक्टली हम नहीं कर सकते, पर एक चीज़ और कर सकते हैं ना. लेट्स डू वन मोर थिंग, कि अगर मैं यहाँ पे डायरेक्टली इसे प्रिंट करूँ. अरे नाइस. ओके, इंट पॉइंटर. अब क्या होगा? ओके, अनयूज्ड वेरिएबल एक्स. हाँ यार, अनयूज तो है. चलो थोड़ी देर के लिए हटा देते हैं. अब ओके, इट इज़ वर्किंग. ओके, सो इंट पॉइंटर वेरिएबल काउंट. अब यहाँ पे 10 आएगा या नहीं आएगा ये देखना होगा. कंट्रोल एस क्यू. सो जी सी सी पॉइंटर दिस एंड लेट्स रन दिस फाइल. पॉइंटर 10 आया है 10. सो वी कैन डायरेक्टली असाइन अ वेरिएबल विदाउट यूजिंग दिस थर्ड वेरिएबल, अगर हम पॉइंटर्स में काम कर रहे हैं तो. ओके, न्यू लर्निंग, कोई बात नहीं. कहाँ था प्रोग्राम? ये था. सो अगर मैं करूँ कि अगर मैं इस लाइन को कर दूँ, फेड आउट कर दूँ, तो असाइनमेंट ही नहीं होगा. अगर मैं कंट्रोल एस भी करूँगा तो एरर आ जाएगा कि अच्छा, कमेंट एरर आ गया. कमेंट विद इन कमेंट, कोई नहीं. कंट्रोल एस. सो यहाँ पे एरर आ गया कि अनयूज्ड वेरिएबल, क्योंकि हमने कहीं काउंट को प्रोग्राम के अंदर यूज ही नहीं किया. डायरेक्ट एंड पॉइंटर वेरिएबल को हम प्रिंट कर रहे हैं. ठीक है. सो हम डायरेक्टली इस चीज़ को कर सकते हैं कि अगर मैं एक चीज़ और करना चाहूँ कि अगर मैं इसे रिटर्न ज़ीरो को हटा दूँ. कंट्रोल एस. प्रोग्राम वर्क करेगा शायद. ओके, एक्स इज इक्वल्स टू एक्स अनडिक्लेयर्ड. हाँ ठीक है ठीक है. कंट्रोल एस. सेट पॉइंटर. अब आंसर 10 10 और फिर 10, तीसरा 10 भी आना चाहिए. कंट्रोल एस क्यू. जी सी सी पॉइंटर काउंट 10 एक्सटेंड 10. हाँ ठीक है, काम कर रहा है. I know about buffer overflow. Learn what I am researching about reverse engineering. Which editor you are using for C? I am using Micro. Researching for reverse engineering. Yes, we will be doing that soon, brother. Firstly, if you are new to the stream, pawn of the board. Firstly, we are targeting penetration testing. Okay, so then the plan before was that we will be going with C programming basics, then C programming for secure coding and malware analysis, and then we will be learning assembly, and then after reverse engineering, because for reverse engineering you need to have the knowledge of assembly and C both. Hmm. I'm researching about reverse engineering. If you want to start, because I will be starting assembly a bit late, around 2 to 3 months I will take because a lot to cover in penetration testing. I'm a Python developer. Nice, good. Good future you will be having if you are Python developer, because the future is all about artificial intelligence and Python is much needed. So if you want to learn about reverse engineering, what you can do, join my Discord. I will be providing the resources from where you can learn reverse engineering. But when I will be starting reverse engineering, it is a lot late, around 10 months, because for covering penetration testing, it's a bit hectic task. Around 10 months will be, more can be, 1 year can be taken for covering a full-fledged penetration testing. Although I will be covering all the streams, all the branches of red teaming, malware analysis, vulnerability assessment, reverse engineering, cloud sex, and what we can do, penetration testing. Anything I have missed? Malware analysis. We'll be covering every single branch of red teaming. There are a lot branches. Uh, Exploiters are also there, exploit developers. So we'll be going brick by brick. Okay, so it is bit understood how it is working now. Let's move to our original program. Allocation memory or non-allocation memory. Okay, I will be. It is covered in this, I guess. Allocation and non-allocation. Allocation is covered, I guess. Non-allocation is covered in Unit 15. What was the program? Micro P2C. Okay. So char, we have declared it here as well. Now we'll be printing these both things. So printf, so it is a character. We'll be using %c, 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 new line character. So what we are printing? First we are printing c, then we are printing this char p, that is pointer, character pointer to character, you can say. Character p, okay. They are ref in C just like C++. There are refs, REFs. What's REFs? Bye bye, very good video for C learners. I was Python developer. Cool, no problem. It's like if it is REFS, it should be written like this. REFS. Oh, I have a reference. So the way of writing REFS was okay. So there's someone that has written REFS correct. So this is the correct way, like capital RE, then file system FS. Hmm. C++, though I don't know about C++ that much, but REFS I don't exactly, I cannot tell, but I think there is no, it is not data structures in CR. I'm not going that way. It is basic C programming, and when it is needed in script making or memory exploitation, binary exploitation, or system exploitation. So at that time when I am telling something about, or I am using a C script, so you should be comfortable. That is why I'm just telling the basics of C programming. Netronics, I don't exactly. I don't have answer. I don't think there is REFS in C. I don't think. It can be done, but there is not explicit syntax. Like I think C++ has explicit syntax for REFS, but not in C, I guess. I cannot tell about C plus plus that much. So, bro, you can teach C for beginner in another live video. Bro, it is for beginner. It is for beginner यार. बहुत बेसिक से ही स्टार्ट किया जब मेरे अगर आई थिंक दिस इज पार्ट 9 अगर यू शुड बी रेफरिंग टू पार्ट 1 वो बहुत बेसिक से स्टार्ट हुआ है उसमें पूरा बताया कि हेडर फाइल stdio.h है, वो भी क्यों है, क्या रीज़न है, उसके अंदर किस किस का डेटा स्टोर है, प्रिंट एफ स्कैन एफ कैसे काम करता है. आई हैव एक्सप्लेन्ड एवरीथिंग. So this is the thing na, the responses I get na ki start teach from basic or start from basic. That is why I have shifted to C programming from basics. It's difficult for you guys if I directly just jump to binary exploitation and write the codes for binary exploitation, system exploitation, working with internal files, है ना. So if you want to uh, learn C from basics, I don't even know one line of C. So you can just refer to part 1 of C programming. Go to my channel, scroll down, you will get part 1. I think part 1 will be stream number 10 or stream 9, 11. I don't know exactly, but you can go directly. So okay, like Bockless and arrays. Arrays I have already taught. Arrays I have already taught. Arrays I have covered. Basics I have covered. Arithmetic operations and all, very basics. Printf, scanf, how they are working, and functions I have covered. User defined functions, structures I have done. Strings, characters, working with strings, and what we have, looping, concept of looping, decision making, if else statement and all of them are done. So let's move till here. Let's see the output. What's the output till here? So gcc p2 p2 c, writing the output to p2. I know web development. Good. If you know web development, p2. So I am getting QQ. Okay, expected output, no problem. If I just remove this Karna from here, what kind of error I will be getting? Control S. So it is saying that it is undeclared. Okay, %c expects argument of type int. Okay, oh, I think I made some error here. So %c expects argument of type int, but argument 3, I cannot read the error, I guess, perfectly. But argument 3, let's do one thing. It is compiled. Okay, the program is running, but since I have not, indirectional operator, that is the asterisk sign, I have not used. So the values, if you see the program, so the value is not assigned to it, because the the C value variable is assigned to this pointer to character, not that char p. Okay, so if you want to access char p is nothing but the address node. So it is a numerical value. That is why if you do control S, it is showing that it is %c, but char p is an integer value, integer variable. So I need oop, it's not C, bro. I need oop, it's not in C, bro. I need oop, it's not in C. I don't get. I don't get your words. If you are talking about object-oriented programming, we are not doing that. We are doing basic C programming, which everyone can join, because no prerequisite is required. Bye, bro. I will watch your videos. Okay. Bye bye. So what we are doing now? So they are changing the value of C to this. This will not work, because let's see it will work or not. Since this slash is already read which one. Okay. If C++ is will be useful in future, I will be referring to that book. So what we are doing now? Printf. Oh, nice. So okay, so we are doing this print again. Nice. Let's do one thing. Okay, what we are doing next? So we are assigning the value to directly to pointer this time. Okay, nice. So char p, that is we have used what we have used. We are assigning a string directly to it, like bracket. Okay, we are printing the same thing again. Shift V. Okay, no problem. Return 0. Program completed. Control S. Okay, lot error. Array, nice. I have, for example, I've taken this now. I have to do that. Control S. Okay, it's done now. Control SQ. Let's try to run this now. GCCP2. Okay, working fine. Okay, so they are doing nothing but they have defined at initial stage when they are just defining the data type of character, they have assigned a value q. Now they are just changing the value or printing the same thing and try to. Okay, so there is a change in this, like uh they have changed the value of this bracket and they have changed the value of the character pointer. But if you have noticed one thing, the value of this c is also changed. We have previously the value was this forward slash. Hello Vyadh, you go flat. It's me Lokesh, remember me. Yeah, wait. You have a community in Discord. Yes, I have a community. Let me just give you a link. The link of Discord. The problem is I give the link in the chat and people say it is expired. I don't know how to give that permanent link. I will see that. I'm not getting time to manage this Discord and channel. So first, let's see this program. What we have done here, we have not directly assigned this, you can say this bracket or parenthesis to C, but we have changed this pointer variable to C, pointer variable of this char C to this parenthesis. And what you observe here is that the value of C is also changed. So this is the significance of pointer. You cannot just directly do by using the third variable. You have to use pointers. Okay. So if it is some kind of another variable like x is equals to c directly and you are working with this, and here you change the value of x to another variable and c is set to this, so c will be printed as it is but the variable will be changed only. Okay. Discord is not running. Nice. Vyadh, today is my anniversary. Can you say happy wedding anniversary to me? Yaar, I don't remember honestly. It's been 3 days, 3 to 4 days. I have done streaming, so I have forgot. Quantum Vertex, I don't. Yeah, I forgot. Today is my anniversary. Can you say happy wedding anniversary to me? Happy wedding anniversary. Bye bye. Enjoy your wedding anniversary, yaar. Why Discord is not working? Initializing update. Checking for updates. Starting. It's taking time. Okay. Done. Finally working. Where is my server? Vyadh. Okay. White people. Discord Safari. Okay. Can we sprint through the topics instead of chat session every 2 to 5 minutes? Yes, we will be doing that. We will be doing that. Firstly, I will be resolving this here Discord thing. I have got this off stream, this error off stream also. Okay. I think someone has given the Discord link already. Yes, someone has, Ayush Upadhyay has given already. He has already given the link. You can join that. I don't know it is. Let me do one thing. Mm, where is my channel? Yeah, I have to see my channel, I guess. Please see if this link is working or not. Let's just shift our focus to the topic. So the character variable C. So I have already explained how it is working now. Let's just not go there. We need to see that particular topic. Pin it. Yeah, how to pin here? Pin. Okay. I think it is pin. Okay. Thank you for helping. So where we are, the previous discussion can help. So till here it is clear. Okay. Till here it is clear. But the catch is we have now changed the value of this character pointer to parenthesis, but the value of C is also changed. So let's find the reason for it. So the previous discussion can help you to understand how the program statement that appears next to the program works unless char pointer is changed. The expression char pointer always reference the value of the C. Therefore, in the expression this, you are assigning the left parenthesis character to C. Okay, so it is indirectly assigned to C. If you assign something to this, the value of C is also changed. So more formally, the character parenthesis is assigned to the variable that is pointed to the character variable pointer. Okay, so it is assigned to the particular variable that is pointed, or you can say pointed to the particular character pointer or this variable character pointer. You know that, okay, so you don't need to specifically write this type of variables. You will get confused like char pointer. It is just the ease of programming, but you can use another variable in place of this. So where we are, you are assigning the left parenthesis, done. So the preceding concept key to your understanding. So this program, why they have structured this program, because they want to make the difference between the pointer and a standard variable. If you are using any standard variable or a plain variable in place of pointer, and here you change the value like x is equals to the parenthesis and try to print the values, so the values will be different because c will be printed as this and the x will be printed as the parenthesis. So this is the basic difference between the pointer. I think my camera stopped working. Okay, it's working fine. Let me just minimize it, but okay. Let's move forward. Use pointers and expressions. Okay, so in program 11.3, two integers p1 p2, where are integers p1? Okay, so they are pointers. P1 p2 are defined, I1 I2 are defined here. So notice how the value references by a pointer can be used in an arithmetic expression. If p1 is defined to be the of type pointer to integer, what inclusion do you think can be made about the use of p1 in it? Okay, let's make this program. Micro p3.c. Okay, so let's take this from here only. So let's start a program. So firstly, we are taking two integers. Let's take I1 and I2. Mm. And also we will be taking two pointers, int P1 and P2. So we can take it here only. Oh, let's make it a bit structured. So P1, comma, P2. Now what they have done. So have they given anything, the statement of this program? No, they are just directly doing this program. Okay, let's see. I1 is denoted as 5. Let's take I1 as 5. Let's practice this program first, then we will be making our own changes to it. I1 is 5. Okay, now P1 is assigned to, okay, assignment operator assigned to uh, P1 is assigned to I1. Okay, I1. Now what is I2 is equals to, it is calling the pointer 1. Okay, so the pointer 1 it is calling, then it is dividing by 2, should be like int. So 5 divided 2, it will be 2 plus 10 12, so plus 10. Okay, so I1 will be 5, P1 will be 5. Okay, P star P1 or pointer P1 will be 5, I2 should be 12. What is P2? P2 should be equal to P1. Okay, so since P2 P1 pointers are 5, so P2 will be also be 5. Okay, one problem. Okay. Mm. Now they are printing the value. So printf. Long time no see. I was wondering, is it possible to make a program in C to connect more than one computers together to process something? To connect two computers. I don't know exactly because see, I have also started it 1 month or 2 months ago. So I think there is some kind of library that can be. We will be using the concept of port forwarding. We will discuss about this later. I will see if there exists some kind of, I cannot directly uh, tell if it can be done or not. It can be done to connect two computers. Any Python program can be written, but for C I cannot. Just S bash scripting can be done. SH program can be written, but for C I cannot tell. Mm, I was thinking of using sockets, web sockets, web sockets. I 2% I P1 pointer one. What they are doing here? Okay. Done. Fine. So percent I, then again pointer P2. P1 points I1. Yes, P1 is pointing I1. P1 is a pointer defined to the data type of this I1, and it is not directly accessing the value of I1. Okay, it is just address. It is just accessing the address node of the I1. Okay, so we have done I1, I2, P1, comma. Uh, here it's a bit confusing. Nice. P2 is equals to again percent I. So 4, only 4 will be needed now. Okay, done. And now I1, comma I2, comma P1, comma pointer P2. Bro, I saw your video about C. They were amazing. Clearly explained. Thank you, brother. So return a donk address day I1 sir P. Uh, are you writing that in some other language or it's not English? Yeah, donk address day I1 sir P1. I didn't understand what you are saying. So control S Q. Okay. So it should be like 5 and what was I2? 12. 5 12 5 5. It should be like 5 12 5 12 5 5 5. Let's see GCC P3 dot C, writing the output to P3. Compiled. Okay, P3. So 5 12 5 5. Okay, working fine. French, huh? I don't know French, brother. I don't know French. I used to have knowledge of French in back 4 to 5 years. I have a subject French, but I don't. I just know like bonjour or Jamapel Ayush. Just this. Jamapel is like my name is Ayush. Just basics. So okay, let's see the program now. Let's try to play with this thing. Okay. Mm, P1 is addressed to I2, I1, but one catch is there. This P2 is not, directly, not indirectly, not directly. It does not, have any connection with that 2 because P2, if you see, it is storing the value of P1. You can say the pointer P2 is storing the value. The address node is same P2 P1. Sprint. Okay, sprint. Thank you for remembering here. So okay, so skip this. If I am just play around with the program, I am not using this book program. I should also skipping this also because I will change the values and try to see what will happen. Will you teach Java? No, brother. No Java. Java is of no use for me. Although cybersecurity is used in networking, but not for me. So let's try to do one thing. If we can do like this, uh, let's see what happens. So P2 we have done like P1 plus I1. So can pointers and standard you can local variables can be added. Let's see, control S Q. Will teach compile print. Okay. So what is happening now? Uh, if I do one thing, we are doing p1 plus a 5. Okay, so let me just explain you one thing before. Since it is an address node, okay, so address node can be, are you a software developer? No, no, I am not a software developer here. I am, you can say, software tester. So security tester. So since it is a address node, so address can be a, big dangling pointer p2. Hmm. That is what I was saying, dangling pointer p2. But I will not be explaining this now. It will come later. I was just trying to play around. Okay. So if you know about dangling pointer, you know why this value have come. Because address node, if you talk about address node, internal memory allocation, the address is a bit, far, 3 to 4 digit number. So at that, this 5, or what we have added, I1 is added. That is why it is doing like this. Let me do one thing. What if we do like this? Yes, same thing. Key assignment to int from int x, because we have assigned int to p2, but we are now in the when we are doing this, what we are doing, expression, in the expression, we have changed in the between, we have changed the value of this standard variable to pointer. We have added a, you can say, indirectional operator before p2. So that is why. So assignment to int from int star makes integer from pointer to standard integer. This is the error. Let's do one more thing. If I do like this, what error it will show? Control S, it is showing same error, I guess. Same thing again. If you want to do the the part of assignment, like asterisk p1 is like I1, I2, I3, you can do like this, but you cannot just use arithmetic operations with pointer. I said that p1 contains address I1. Yes, address. I said p1 contains the address of I1. Yes, p1 contains the address of I1. So let's just, okay, control is, it's working fine now. Okay, let's move forward. I think they have given any kind of hint for the dangling pointers. I don't know whether it is covered in dangling pointers is covered in this unit or not. Let's move forward. So I2 p1. So yes, what that I was telling. If you want to access a pointer, you have to use a asterisk sign. Okay, if you are assigning a value, you don't need to use asterisk sign. It will show you error because you have already defined that it is an integer. Okay, so in as applied from the discussion of program 11.2, if a pointer px points to a variable x and px has been defined to a pointer to the same data type as is x. Okay, so pointer and the variable both have the similar data type, then use of a star px in an expression is in all respects, okay, identical to the use of x in the same expression. So you cannot just directly use a pointer without asterisk if both the data types are same, if we talk about the standard variable and the pointer. Okay, so because in program 11.3 the variable p1 is defined to be an integer pointer, the preceding expression is evaluated using the rules of integer arithmetic. Okay, so p1 is defined to integer. Okay, p1 is defined to integer here, and what it is doing, so the preceding expression is evaluated using the rules of integer arithmetic, and because the value of asterisk p1 is 5, p1 points to I1, p1 is pointing I1 and asterisk. Okay, so this is calculated first, and if you write the expression like this, star p1 will be calculated first, like it is pointing to the value of I1 this time, and where were we? So the final result of the evaluation I have already told how it is 12, because since it is an integer, so 5 divided by 2 will not be 2.5, it will be 2. So 2 plus 10, 12. So let's move forward. So working, I don't think so dangling pointers are discussed here. No, they are not discussed here. They are moved directly to the structures. No problem. So working with pointers and structures, you have seen how a pointer can be defined to point to a basic data type such as an integer or character, but pointers can be So what happened is P1, like the numeric value of the address, got I1 value added to the it. So P2 now points to a cell which has no value stored. Yes, exactly. But the case when we have taken P2 is equals to P1 plus I1, what happened there is that they are treating the whole expression as integer. So now they are, directly indicating to the address node of the particular variable. So address node are of, 3 to 4 digits. In this we have seen it is of, I think, 10 plus digits. So I don't know exactly it is bits or bytes. I think it is blocks, and small b can be denoted for, a particular address node, for addressing a particular address node. So this is the address value that is fetched from the internal memory while we are allocating some kind of variable. You have to explain pointer in array. You have to explain, okay, if it is covered in this unit, I will explain. If it is not, I will explain it tomorrow. No problem. Let's see. So okay, so working with pointers and structures. So if you have seen how pointers can be defined to point to a basic data type such as int or char, but pointers can be defined to point in structure in chapter 9, working with structures. So this is the way of defining a structure. It is like struct keyword, and we are defining a date. In that date, it consists of month, day, and year. So int is used because all are in integer. So okay, sorry. Where were we? So is there any program? Okay, they have the program. Let's make the program directly. So micro p4 dot c. Okay, hash include stdio dot h. Hmm. Int main. Oh, nice. Int main word. Okay, I guess let's take a break because I think my webcam is disconnected from battery. Uh, yes. I have to adjust this. Okay, so okay, that's easy. Okay, no problem if it is easy. Sorry for taking time. If that's easy, let's just directly jump to the program, what they are doing. Program to illustrate structure pointers. Okay, so int main void. Okay, so they have defined a structure here, struct. Nice, 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 nice. I think, see, okay, fine. So let's just define a structure here, struct, and we are defining a date. For structure, we will be using curly braces again. What we are defining int. So let's use this day, month, year type. Int month, int year. Structure is defined. We need to terminate with semicolon. Okay. So now we'll be taking another variable that is defined as a structure. So structure date. Let's take today day. What they have taken today. Okay, today. And date pointer they have taken in the single line. No problem. Date. Let's take date p. Okay. Pretty basic. What they are doing now. So now they will be doing the same thing. I guess date p, assigning the value this today. Okay, similar thing. No problem. Let's do. We have done with the assignment. Now what they are doing. Hmm, today's day is 9:25. So it is a way of representing date in terms of pointer. So I guess they have used this. Okay. Have they told this before? The structure pointer operators. Okay, so this is a operator will be which will be used in structures. So which is a dash followed by a greater than sign permits the expression that would otherwise be written as this. Okay, so in structure, when we are doing, so we are doing like today dot day or today dot month, today dot year. So we are assigning the value like this. So in this case, okay, so in this case, what we are doing, since today, we know that today, this variable today is a pointer. So we are defining the pointer, then now dot y can be set as month, date and year. Okay, so it is a way of writing like this. You can write like this or write like this, same thing. So let me just tell you first how it is written. So when previously when we are try to enter a date, so we are using like today dot date is equals to then today dot month and today dot year, like this we are denoting. But now since it is a pointer, we are working with pointers, so in place of this what we are doing, we are using date p. We cannot use dot because we have to define it as a pointer. So what we are using instead of dot we can write like this. uh, okay, and it should be working, I guess. Okay, so date p here, date p here. Okay, take in the so we can just what's the date today? 1 November. 1 date, month is what month it is, what month it is, 11. Okay, and year is 2026. 2026. Okay, so okay, done. Now we are printing the date. Printf. mm, Today's date, so today's date is, and since it is integer, so we will be using same like percent I slash percent I slash percent I new line character, and how it is defined. So this will be used. Okay, so they are using complete this and this. Did percent year divided by 100 because they want the last two digits, but we will be taking the full year. So shift V, comma. Yes, this is the legit syntax, you can say, but it is a way of writing. I have already. That is why na, I read the text because you get to know everything. But now you are saying to sprint up, and that is why I skipped that part. Where was that? Using pointers in expressions, I guess. Where is the page? Yes, this was the important part. My professor said this day won't work. This will not work. This will not. No, I think. Let's read this, Nayar. Why to get confused? I think it is working. Let's try to do this also. Let's try to finish this program, then we will be doing this. I also don't know what will be working. I am just following this book. So to test the value of the month stored in the day structure using this. Okay, so it can be used. Pointers to structures are so often used in C. As a special operator exists in the language. The structure pointer operator. Okay, structure pointer operator, which is the dash and forward. Otherwise, okay, would be otherwise be written as this. It can be written as this to be more clearly expressed as this. Okay, so it is a way of writing, but it should work. It should work. Both the syntaxes are legit. Both are legit, but it is a way of writing. We will see how it will be working. I think I have made an error. Date p dot. Yes. Because it is like date p month. We have to copy it whole. So date p date. Shift V, comma, Shift V, comma, It's not covered. Date p, date month. Two errors. Has no member name date. Okay, I have written day here and taken day. Okay, sorry. Day. Printf here, this before this token, expected this. Okay, I think I have written colon at the end. It should be working now. Control SQ. Today date is 1/11/2026. Okay, so working fine. So let's try that syntax also. So it is like starting the bracket, pointer, then using date p and date p. It was like this, na? I have to use dot also. Dot. This was the syntax, I guess. Yes, it is. So let's change it here only, na? Let's try to change this only. If one is working, everyone will be working, na? Arey yaar. Control Z. Okay, so parenthesis, then asterisk, date, p, the variable, and later the dot. Control S. Okay, no error. I think it will be working. GCC P4. Unfortunately, Netronics Nin, your professor was wrong. It's working. It's working. Fine. You can see this is also working. This is also working. I don't need to change all the, because if one is working, everyone will work here. So you can write like this. You can write like this. This is a bit easy to write because just a hyphen and greater than sign. Yeah. Okay. Okay. Good doubt. Yeah, I can't guessed he was wrong. He was a college professors. Yeah. What do you expect? So date pointer is pointing towards the structure today, and it's not directly accessing the value. It is direct. It is only accessing the address node of today in that dot month dot day and dot year pointer to a structure. This is a correct way. So once again, it should be pointed out that there is no real motivation shown here as to why you should even bother using a structure pointer when it seems as though you can get along just fine without it, as you did in program 9.1. You will discover the motivation shortly. Okay, so they are just, if someone reading this book get bored why you are using pointer, because this can be done a bit easy way, so they are just motivating us because it will be told us shortly. So structures containing pointer. So in this, it is without pointer. We are just using pointers outside the structure, but now we are making a structure that consists of pointers. Pretty good. Let's make this program also. Control SQ. Control SQ. Okay, so micro p5 dot c. Okay, done. So till here is the same. Shift V. Okay. After that, what we are doing now, let's read it first. Naturally, a pointer also can be, okay, a structure called int ptrs, int pointers, okay, is defined to contain two integer. So you should not go with the name because it can be different. So the first one called p1, the second one called p2. Okay, second one is p2. You can define a variable type struct int pointers. Okay, since we are working with int pointers, so they have taken a easy name, so it can be a bit recognizing. Int pointers in the usual way, struct int pointers. Okay, so variable pointers can now be used in the normal fashion, remembering that pointers itself is not a pointer. Yes, this is not a pointer. Okay, you should not be get confused. This is a variable which is defined that it should be working like a structure int ptrs. Okay, so this is not a pointer. This is a pointer. Okay, so the variable pointers can now be used in the normal fashion, remembering that pointers are it's pointers itself is not a pointer. This variable is not a pointer, but a structure variable has two pointers as its member. Okay. Oh, okay, working fine. Let's write this program. So structure and ptrs, till here it is same. Okay, so we have defined a structure in ptrs in which we have taken two pointers p1 and p2. Now what we are doing, we are using this struct in pointers and int ptrs. Okay, and we are defining a new variable which is, which behavior depends on the structure. So let's use pointers. Okay, working fine. What we'll be doing now, so this is a way of we will not be doing that stuff here, this thing not be doing, because here date ptr was a pointer, but it is a standard variable, it is not a pointer. So we'll be using the old logic of that structure. So in this they have taken int I. What they are doing here, what they are doing, I is equals to 100 pointer one. Okay, okay, got it. So now they are taking two integers, int I 1, which is equals to 100, and I2 is nothing. Nothing is defined here, nothing is declared here, it is an integer. Now pointers dot p1, it is accessing the p1 pointer. Now this is allocated to this variable address node of I1, and pointers pointers dot p2 will be access the value of the address node of I2. So and I2. Okay, now what we are doing, so since we need to fetch the value, so for fetching the value we'll be using that indirection operator, and we'll be using pointers dot p2, because we want to denote or assign a value to I2, so we can just directly write like this 97. So at initial state we have not defined any value, but we are now accessing that address node. Inside that we are interpreting this value minus 97 to I2, because we are in the address node of I2. Pretty good. Now they are printing, so let's not waste our time in this directly writing this. Okay, so in first it is writing the values of I1 and pointer 1, and in second, okay, so when you want to access the value, I have told you many times, you have to denote it with asterisk, and when you are doing some kind of operation you can just go directly. Okay, uh, here is also it is accessing the value, here it is assigning a value, so both asterisk will be used in both the cases, because we need the value na. So for extracting the value you have to use that indirectional operator. Okay, so the bracket is closed or not. Mm. Okay, so return 0. Control S. Okay, now what we have to do, gcc p5 dot c, writing the output to p5. Okay, now we will be running this p5 directly, hit enter. Okay, it's working as I have said it. Okay, what's the duration of the stream? 180 minutes. Let's take a break. Let's take a 1 minute water break, and I will be continuing soon. Okay. So let's resume again. Hmm. So it is clear. I guess it's pretty basic, and do not need to read that also. Okay, so now we are going to linked list. Okay, so that it is a topic of data structures. I think it will not be covered that much, but okay. So you to create sophisticated data structures such as linked list, doubly linked list, and trees. Now, yes, okay. So I think they have given a basic introduction of data structures. Nice. So the concept of pointers to structures and structures containing. So the key, the one try Android dev alongside. No, Android, not Android development, but I will be going for Android pen testing, iOS pen testing both. So linked list, I was emphasizing on 3 to 4 words like address node, addresses, and pointers. So I think all will be covered now, and you will be get along with it. So the concept of pointers to structures and structures containing pointers are very powerful ones in C. So for they enable you to create sophisticated data structures such as linked list, doubly linked list, and trees. Suppose you define a structure as follow: struct entry, int, struct entry. Okay, so you are using structure inside a structure. Uh, asterisk next. Okay. Uh, is this some kind of page? Because it should be before, na? Let's see. 245, 245, 244. Why this program is here? Why this diagram is here? I don't know. So this define a structure called entry, which contains two entry. Okay, huh. So which contains two members. The first member of the structure is simple integer called value. Okay. Second number of structure is called second member of the structure is a member called next. Is a member called next. Okay, but it is structure inside a structure. Okay, no problem. So I think it is some kind of infinite loop. Let's see. So think about this for a moment. Contained inside an entry structure is a pointer to another entry structure. This is perfectly valid concept in C language. Now suppose you define two variables. Okay, same error, same doubt you can say. So now now suppose you define two variables to be of type struct entry as follow, like struct entry n1 and n2. Okay, so we are making n1 and n2. These are not pointers; these are variables. Mm, okay, so you set the next pointer of the structure n1 to the n1 to point to structure n2. Okay, so n1 is pointing to the structure n2. Okay, that is how it is working. It is not an infinite loop. They have for marking the end of this loop. They have done this thing. N1 is equal n1 dot next is equals to n2, and they are assigning the n1 next to the next structure, that is n2. So yes, set the next pointer of the structure n1 to the pointer uh, to point to the structure n2 by executing following statement. Hmm. So this statement effectively makes a link between n1 and n2 as depicted in figure this. Okay, n1 value. Okay, so this is going here value, then this again n2 and so on. Okay, here value 100, 200. Okay, so the next variable inside this, the structure is accessing the first node of this. You can say it as header node if you are talking about linked list. Send the base value again connected to n3. Okay, so assuming a variable n3 were also defined to be a type of structure entry, you could add another link like n2 next. Okay, n2 next is equals to n3. Okay, so this resulting chain of linked entries known formally as linked list is illustrated in program 11.5. Figure 11.5, program 11.6 illustrates the string linked list. Okay, let's make this program micro linked linked list dot c. Let's take this from here only. Should be okay. So inside the structure entry, we are taking a simple integer that is int value, and we are taking another structure inside this, which is itself struct entry. struct entry, and we are taking as pointer next. Okay, let's close this. And what we'll be doing now, we need to define the variables. So struct entry, or what is this entry na entry. We are taking three variables, n1 comma n2 comma n3. Okay, now what we are doing, so we are defining the value n1 dot value is equals to 100. Then okay, n1 dot next will be uh, you know, will be linked. If you are talking on linked list, will be linked to the n2. So for that, n2. Okay, pretty clear. Then what we'll be doing, n2 dot next, we are pointing to the next structure, that is n3, and that is how the chain works. N3. What next? What next they have done? They have, okay, they have taken another integer enti. What they have done with this enti? So I is equals to, okay, let's see how it is working. I is equals to n1 dot next. Okay, again denoting to the next structure. And okay, so n1 dot next is a pointer. Okay, good question. What will be the end goal of this entire live cohort? Hack SBI and be a millionaire. I wish I could. I wish I could. But you cannot just hack SBI servers with this C programming or especially pointers. But what you can do, if you are interested in bug bounty, I don't think so SBI, because you know Indian government websites are not that much powerful, so they don't give that bug bounty thing or programs. I think they give or don't, I don't know exactly. But if you talk about SBI, there can be a possibility they have a misconfiguration in the memory allocation of anything. You can exploit that. Go on. But I will not be any kind of responsible for this. It's your own call. I'm not insisting or teaching you to hack SBI or all. It's your choice. So since it is a pointer, so we are just okay. So we are assigning the value of I to n1 next dot value. So it will be like n1 next value. It will be 100. Okay, it should be 100. So we are printing this printf percent I, comma I. Okay, what they are printing? They are printing this also. Shift V. What is this? Okay, n2 next value dot value, you can say. So the pointer n2 dot next and the value of this n2 dot next, it should be 200. 100 and 200. Nah. N1 next dot value. N1 next dot value. N1 next dot value. So N1 next is N2 na. So N2, it is like N2 dot value. And if you are asking for N2 dot value, it will be 200. It should be 200 na. And here what they have done. Okay, so the purpose of I is that you can store the values in a particular integer. N2 dot next is nothing but n3, and n3 dot value is 300. So it is not 100, 200. It should be 200 and 300. Yes, it is 200 and 300. Okay. Pretty good. Wow. Control S. Wow, errors. Nice. So GCC, linked list, output, linked list, linked list, enter 200 and 300. I have not left that space. Now that is why it is in the same line. 200, 300. Okay. Pretty clear trail here, na? Okay. So let's move forward. How much is there in pointers? How much extent they have gone? They have covered linked list. Okay, explaining the same thing. Okay, traversing a linked list. Pretty good. Clear. Keyword constant. Okay, constant pointers. Pointers and functions. Okay. Returning a pointer from a function. Pretty clear. I'm just seeing. Okay, pointers and arrays. Someone has asked now pointers and arrays. There are. The topic is also covered here. Pointers and arrays. I think full chapter will not be covered today. I know pointers will be. I have to divide it in two parts. Okay, constant character strings and pointer. Okay, characters and string together. Again, doing that same shit. Revised version of copy string. Okay. Operation on pointers. Okay. Pointers to function. Okay. Using pointer inside a function. Okay, no problem. Let's pull a whole nighter. Easy for you, yeah. Not easy for me. I'm not that much of. I'm working for a whole day, yeah. If you see my past streams, I have done 4 hours, 3 hours. But when I have a hectic day, na, I cannot go. I cannot even touch 2 hours. Wait a minute. Wait a minute. Oh, I got a call. Sorry for the interruption. कल संडे है, ऑफिस नहीं जाना होगा भाई. मैं ऑफिस में हूँ भी नहीं. कौन कह रहा है? ऐसा नहीं है भाई. क्या ड्यूरेशन हो गया स्ट्रीम का? 136 हो गया ना, 1 hour more till 12 we will be uh, extending this. Okay. Mm, okay, till 12 we will be extending this, no problem. So pointers and arrays, no, where we were. Nice, we were in linked list, na? Linked list we are discussing. Okay. So structure n1, n2, n3 are defined to be a type of structure entry which consists of an integer member called value and a pointer to an entry called next. Okay. So the program then assign the value 100, 200, 300. Okay. The next two statement in the program n1 dot next, it is pointing towards the structure n2, and this is pointing towards the structure of n3. Set up the linked list with the next member of n1 pointing to n2 and the next member of n2 pointing to n3. Execution of the statement. So this statement proceed as follow. Let me open the program here. Okay, so we are talking about now this statement. So the value member of the entry structure pointer to by n1 dot next. So n1 dot next is nothing but n2. So is accessed and assigned to the integer variable I. Okay, so because you set n1 dot next to the pointer to n2 value member, so n2 is accessed by the statement. Okay, directly. So now, therefore, the statement has the net result of assigning 200 to I, because we are in N2, we are accessing this value member, and that is why 200 is allocated here. So you might want to verify the expression this is the correct one, and to use not this, because n1 dot next field contains a pointer. Already know that n1 dot next is a pointer here by this. So we need to follow that syntax like this, or the old OG syntax you can say. So for the structure member operator dot and the structure pointer operator, this have the same precedence in the C language. Okay, so in expressions such as preceding one, where both expression are used, the operator are evaluated from left to right. Left to right. Okay, so therefore the expression is evaluated as this. So this has and this has same precedency, but in C we have to move from left to right. So first n1 dot next will be calculated. Since n1 dot next is nothing but n2, so n2 is assigned to I, then we moved forward. So firstly this is assigned, I is assigned as n2, then we move forward to the value member and then it is assigned to I. Okay, which is what's intended. So second printf call displays the value member that is pointed to by n2 dot next. Because you set n2 dot next pointer to n3, n2 dot next, n2 dot next to n3. Okay, the content of n3 values are displayed by the program. Okay, so as mentioned, the concept of linked list is very powerful one in programming. Linked list greatly simplifies operations such as the insertion and removal of elements from largest or sorted items. So for example, n1, n3 and n1, n2, n3 are defined previously. You can easily remove n2 from the list simply by setting the next field n1 point to whatever n2 is. Okay, okay, so you can just directly, if this is the case, like n1 dot next, it can be directly go here, and since n2 dot next is nothing but n3, so this n1 next will directly access this n3 and will not come here. Okay, so this is how you can just remove something from a linked list. Okay, so inserting an element into a linked list is just as straightforward. Okay, they are taken another linked list n2 dash or underscore 3 dot next. Okay, so n2 dot next is n2 dot next is nothing but n2 dot next. Okay, so n2 dot next, this value will be assigned to where it is going here, but okay, so in the next line n2 dot next. Okay, so it is referring to the n2 underscore 3. So it is now accessing this value, and since n3 is already there like this, n2 dot next and 3, so after finishing this, or you can say adding this, it is moving like this. So you can just rearrange, and the diagram, you will get the proper diagram. I think they have not given the proper diagram. So after n2 dot next is directly accessing the value inside this n2 hyphen 3, and then this n3. Okay, no problem. So we have done insert, we have seen insert concept of, you can say, algorithm of insertion and deletion of something. Okay. Before developing some function to work with linked list, two more issues must be discussed. Usually associated with a linked list, it at least one pointer to the list, often pointer to the start of the list, is kept. So for your original 3 element list, which consisted of n1, n2, n3, you can define a variable called list pointer and set it to the pointer to the beginning of the list. Okay. Okay. So we have to, set it to the beginning. Hmm. Struct entry. Okay, so you cannot just like here we have leave it blank. It is suggested that we have set, should be set to n1 first. Okay, assuming that n1 has been previously defined. Okay, so it should be defined previously. Okay, 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 okay. So you can do one thing. You can define it previously and do that stuff, no problem. But the problem is uh, when you are using this list pointers, and like if you want to do something like this, if you are making another pointer, so you can just do like this pointers, because you want to make a list now pointers, and you have to set it that it should be starting from 1, so it should be allocated as n1 previously. You can do like this, but it is suggested to like write like this, not plus, it equals to. Okay. ठीक है. So is your 3 entry list, you can mark its end by storing the null point. Okay, I think I have missed something. So the second issue to discuss involves the idea of having some way to identify the end of the list. This is needed so that a procedure that searches through the list, for example, can tell when has the reach. Okay, okay, okay. So the two problems that we are facing while we are working with linked list is that with the beginning of the linked list and ending of the linked list. So for the beginning, we can just directly assign like n1, and for ending, what we are doing. So the final element in the list. So by convention, a constant value of 0 is used for such purpose and is known as null pointer. Okay. So n3 dot next struct entry pointer and 0 null pointer. Okay. So you can use the null pointer to mark the end of the list by storing the value. Okay. So C programming does not know if your linked list is ended or not. So you can just assign a null pointer if you want to end the linked list. So you see in chapter 13 the preprocessors, how you will see hona chahiye. You will see in chapter 13 the preprocessor, how this assignment statement can be made a more reliable or readable. So the type cast operator is used to cast the constant 0 to the appropriate type pointer to struct entry. It is not required but makes the statement more readable. Null, yes, null pointer. Let's just directly jump to the program. I am doing a stream, after 3 to 4 days. Now I lost the habit of streaming for longer time. No problem. No problem. Control SQ. Mm, Micro. What's the program? Traversing a linked list. Traverse. Dot C. Okay. So till here, we can just directly write. So inside this, we are defining two members, that is int value, then struct entry, struct entry, and next. Okay. So a null pointer is not necessarily okay. So they have given the definition, I guess. A null pointer is not necessarily internally represented as the value 0. However, the compiler must recognize the assignment of constant 0 to a pointer as assigning the null pointer. So this also applies to the comparing a pointer against the constant 0. The compiler interprets it as a test to see if the pointer is null or not. Okay, no problem. So now the same thing that I was telling, struct entry, we'll be using three variables n1, n2, and n3. And now what we are also doing, so what is your background in education? Are you a first year student? If you want to study, continue with the stream. Why you are interested in my background? If you are enjoying the content, you can enjoy. Do you need a proof that if you are studying from a YouTube or some platform, do you need a proof or degree something that if you have degree, we will be studying from you? Is that so? Because I can show you, no problem. Struct entry. Okay, so we are working with pointers now, so we need a pointer here. So let's take list. And again, the problem, first problem we need to do that is assigning it to as n1. Okay, nice. Now n1 dot value is equals to 100, n1 next is n2, n2 value is this. Okay, till it here it is same, no problem. Shift V. I think we can make the changes in the old program. You should make the changes on the old program, no problem. So now what happens? Till here it is same, this line and this line. So this is the different thing that we have added here. Like we are marking the beginning of linked list, and now we will mark the end of the linked list. How it is done? So struct array struct entry, and since it's a pointer, so we need to define a pointer now, and since it is a null pointer, we will be defining it as 0. So you can say it is a syntax or something. Okay, so n3 next is address the value address the address is assigned the address node of null pointer. So it is not addressing anything. So if it is not addressing anything, C programming will look into it like what it is addressing to, and it is a null pointer. So it will be C programming or the compiler, GCC compiler, what it will be assuming that it marks the end of the linked list. Cool. Now what we need to do, what they are doing here, what's the output? They are printing the n1 n2 value. So list pointer 100, then 200, 300, then 0. Okay, so they have taken one condition while list pointer is not equal to the null character. So while list pointer or not, why follow such long syntax? Which syntax, whether which syntax are you talking about particularly? Like this, I have taken to struct entry here. So we are dealing with list should not be is equals to the null pointer. So struct entry null pointer 0. What it should be executing, it should be printing the values, I guess. Printf percent I, since it is an integer na, percent I, marking null character. And what we need now, way of representing, nothing, since only way of representing. If it will also work if I leave it blank. I will not write this line line this n3 dot next. Just the simplicity. If am reviewing my code later in future, uh, I can see or I can assume that it has a null character. Nothing much. I hope I answered your question. If I leave this blank, na, I remove this line, it will also work. है ना? So list inside list n1 n2 is there. So list, we'll be using that same thing. We need to access the value now. No, like what is the difference if we use null instead of struct? No difference, brother. No difference. No difference. Let's see ना, इसको complete करते हैं, उसके बाद देखते हैं क्या होगा. Value. I have to see if there is an internal difference. There can be a possibility if there is an internal difference. So inside list we are accessing value. What value we are accessing exactly? List pointer. This list pointer is here. Okay. List pointer is from here. Okay. Again my webcam. Okay. So what we are doing? We want to print the value now. Okay, so we have printed now. List is equals to list. We are accessing the next this next member. Since it is a pointer, we will be using that again. Next. It should work. Okay. Return 0. Start the program, end the program, control S. Much errors. This before and token. Okay. No semicolon. I have put the semicolon, but okay. It's a pointer na. Control S. Sorry. Control SQ. Okay. So GCC traverse.c. No. Traverse.c. Writing the output. Traverse.c. Oh. Hundred, 200, 300. Working fine because we are printing the values na here. Okay. Till when we are printing, till this list pointer is not equals to the null pointer. When it is equals to the null pointer, it will stop printing the values. Pretty simple, not that much complex. So this was the condition I need to see now. List pointer is equals to list. So the list, we can say list is equals to list dot next. Okay, so I think it is accessing the next what we can say next n2 or n3. No? Here it is. The statement that follows the printf call this has the effect of taking the pointer from the next member. Same. Taking the pointer from the next member of the structure pointed to by list pointer and assigning to the list pointer. Okay. So it is taking, or you can say the fetching the next member and assigning it to the another n2. Like if it is fetching from n1, it is assigning it to n2, then n2 to n3, n3 to n4. Running a chain, you can say. Okay, so because the value is not null, it's the pointer to the entry structure n2 and the while loop is repeated. Second time through the while loop, result is display of n2 dot value, which is 200. The next member of n2 is then copied into this list pointer, and because you set this value to the pointer n3, n3 is called. Okay. Okay. Done. So till we are running till the condition of null pointer, And what we are doing, this is nothing but it is just printing the values, and it is accessing the next value, or you can say next structure. Like if it is on n1 and printed the value of n1, then what this line is doing, or what this syntax is doing, it is accessing n2 now, n2 structure. Pretty basic. So keyword constant pointers. uh, Today I have not that much of energy to continue, I guess. My neck is already started paining. Okay. So till where we can cover. Keyword constant pointers can be covered today. Pointers and functions. And let's do it till array. Array. Okay. So array, we will be doing array tomorrow. Okay. Let me see if I can have two streams tomorrow for the compensation of today, because I need to complete pointers today. From the when I have started the stream, I have aimed that I will be streaming till 1 or 2, but my neck is not allowing, I guess. No problem. We will be completing till pointers and functions. So pointers and working with the pointers and functions, yes. So keyword const and pointers. Const, I have already told, it is some if you write const pre to a variable, or अगर आप const variable से पहले लिखते हो, you write before variable, so it is defined as a global variable, and throughout the program the value will not be changed. So you have seen how a variable on an array can be declared as const to alert the compiler as well as the reader that contents of the variable and array will not be changed by the program. Or with pointers, there are two things to consider: whether the pointer will be changed and whether the value that the pointer. Okay, so we have done a program now where we have changed the value of the pointers and the original variable is changed. So let's see here what happens if we do const, and the property of const, the value of the const will not be changed throughout the program. So what do we need to read this? Char c is equals to x, char ptr. Okay, the pointer variable char is set pointing to the variable. Okay, done. Char pointer const char ptr. Okay, so it can declared as a const pointer. So syntax will be a bit changed. There will be spaces. So you cannot just like char const and write this. You have to do this asterisk before. So if the pointer variable is always set pointing to c, it can be declared as const. Okay. So read this as char pointer is a constant pointer to a character. Okay. So variable is not constant. The pointer is constant. That is why we have taken the this what you can say indirectional operator before const, because the char ptr is not constant, the pointer is constant. So a statement like this, char ptr and d, not valid. Okay, so this will not be valid now. So what error it will show? Causes the gnuc compiler to give you message like this: fooc10 assignment of read only variable char ptr. So compiler may give a different warning message, no message at all. Okay. Okay. So now if instead the location pointer to by char ptr will not change through the pointer variable char ptr, that can be noted with a declaration as this: const char, the similar that I was telling, const char star. So read this as char ptr points to a constant character. Char ptr is a constant pointer to a character, and can ptr points to a constant character. Okay. So this time the character is constant, but in this case the pointer was constant. Okay, so these are two different ways of writing. And what changes we have made? Const here. Nothing, just const before all the things. All the syntax is okay. In this case, char ptr was not working. In this case, the pointer will not be working, because since it is a constant, na, the pointer is constant, na, so it will not be changed. You cannot assign a value to it. And here the character is constant, so you cannot change the value. Okay, so in this case in which both the pointer variable and the location it point to will not be changed through the pointer, the following declaration can be used as this. So let's move to the directly to the program. Okay, we can just combine this both constant character and constant pointer. So first use the constant const is the content of the location, the pointer reference will not be changed. The second use says that the pointer itself will not be changed. Okay, admittedly this looks like little confusing, but it's worth noting at the point. Okay, ठीक है. Keyword const is not used in every program example where it can be employed, only in selected example. Until you are familiar with reading expressions such as previously shown, it can make understanding okay. They have not given any program. Nice. Let's make our own program then. Let's use that. What program can be used? We have done p2 na, cat p2. It was p2 or p1, cat p2.c. Characters we have done here now. Okay, so micro, not cat p2 dot c. Okay, what changes we have to add here now? In the first one, you can do like when the pointer is constant, but in second, yes, the vice versa. Like this can be done in the first case, okay, pointer pc, and this can be done in the second case, vice versa. Yes, p is equals to Andy, not pointer p, because here pointer p is not constant, the character is constant. So what we will be doing now, how do I change this? Let's do one thing, or not delete, not delete. Okay, and one more thing, char. Okay. So this cannot be done now when this cannot be done. This cannot be performed if we like write like this. But in this case, it should be working now. Char const char ptr is equals to %c. Okay. Also, okay, so they have taken the same example, I guess. So let's in first case we are making the constant. The constant thing is pointer. Okay. So const. Okay. Now if I do this, what will happen? Control S. This before this. Char const char p. Okay. GCC p2.c. Okay. Since the pointer was constant. No, this was not my target. I want to do one thing. I have understood this thing now. I want to implement another thing, p2.c. What if I do this as const? And this is same. If this is constant now, and we try to change the value of the pointer, so this should be q now. It be like either there are two options. Either if it is an error, okay, I should move there now. So two cases. So output will not be like parenthesis and parenthesis. So three cases can be said. I cannot. Let's save it first. Okay. Okay. Const qualifier pointer target. Okay, so because we have fixed the value of q now, and we try to change, and we are accessing the constant value of char. We cannot do that. We cannot do this. Okay, we cannot do this. Let's try the fourth case. Fourth case does not exist here. First case is we change the first case was that we change the this char c to const. We are fixing it as constant value, but we cannot do that because we are working with pointers. And we have seen if we just do this const here in the character.p, character underscore p, hmm, the value was same, parenthesis and parenthesis. What if I do one thing? What was the case? This case, na? Fourth case. Const char and star, again const and star again, asterisk, you can say asterisk, char ptr control s. Okay, now they have two errors. Assignment of read only location. Okay, because you cannot do like this, because here what you have done, char ptr points to constant character. Here you have also made this character constant. So I have to do one thing. I have to remove this const, and I think it will be working now. If I do control s, okay, it is not showing any error. But if I like do control z here and remove this const and write like this, const char ptr. If I do control s, it will show error. It will not, it cannot be running. And what I have to do in this case, they have taken this case now, cont char. Okay, they have taken this case, so it won't be changed like this. Control s. Okay, so const char, I cannot write like this. Okay, but I can write like this now. For that, if I remove this and control s, directly not accessible. But if I just remove this line, control s, it will be working fine na. Control s q. QQ will be printed. Yes. But if I want to print parentheses, if I want to print the parentheses, what can I do? In that case, we have like done like this na, char p, and set it as this or this. We have done like this, but we do control s, it is showing this error. If we remove const to control s, what error it is showing now? Sorry, it will be working fine. But if we write const control s, it's showing error. But if I do const here, it will not show error. Control s, not show error. But I have to do one thing. I'll be writing, making this character constant, like this. Okay, but I want parenthesis to be printed here. But if I do like this, it will again show error. So what you can do here, C, cannot just directly change the value from the pointers. So you can do like this, C, we are building parenthesis now, parenthesis, and what you can do here, can do and C, control S. So parenthesis will be printed in this case now, control S, Q, GCC. Okay, done. Error. Okay, error in that case. The const, if we put that const in between and try to run with the asterisk. Okay. So I was seeing that if I do the character constant, but I still want parenthesis to be printed. It cannot be possible to print with the pointer only. I have to change the original value of the original variable. Like I have changed here. I have changed the value of the original variable. I cannot just directly do like that कि हम parenthesis को char p में denote कर दें. Okay, 2314. So pointers and functions. So pointers and functions get along quite well together. That is, you can pass a pointer as an argument to a function. Okay. Okay. So argument, you all know in functions, argument is how argument is defined. So the first case cited previously, passing the pointer argument, is straightforward enough. The pointer is simply included in the list of the arguments to the function in the normal fashion. Const char, const ptr. This will also not work. Const char, ये तो syntax ही wrong है यार. Const char, const ptr. नहीं, सिंटेक्स रॉन्ग हो जाएगा यार. पीटीआर जो है ना, पीटीआर पॉइंटर, उससे पहले भी एक एस्ट्रिक आएगा. ये तो सिंटेक्स ही रॉन्ग हो जाएगा. पीटीआर से पहले भी एस्ट्रिक आएगा शायद. कहाँ चला गया? ये रहा. ये तुम्हारा वो है ना वेरिएबल पीटीआर. नो, सिंटेक्स करेक्ट. भाई सिंटेक्स चेक कर लो यार. मेरे ख्याल से गलत है. पीटीआर से पहले भी एक एस्ट्रिक आएगा, क्योंकि मैंने रन करके देख चुका. मैं कॉन्स 2 बार ऐड कर लिया तो वो एरर दिखा रहा था. बिकॉज वी आर मर्जिंग बोथ द केस ना. फर्स्ट केस वॉज कॉन्स्ट पहले रखेंगे और पॉइंटर को कांस्टेंट करेंगे, तो वो केस भी लिया है. और सेकंड केस में हमने कैरेक्टर को कांस्टेंट किया, तो वो केस भी लिया है. तो 2 बार एस्ट्रिक आएगा, 2 बार इंडायरेक्शन होगा. एक बार इंडायरेक्शन कैरेक्टर की तरफ से होगा, एक बार इंडायरेक्शन पॉइंटर्स की तरफ से होगा. सो तभी ना क्यों हम छोटी छोटी चीज़ों पे इतना, वाई वी नोटिस दिस स्मॉल डिटेल्स, बिकॉज asterisk we all, if you tell a normal thing that asterisk is used in pointers, it will be used as it is कि भाई syntax है. बट asterisk का मेन काम क्या है? ये इंडायरेक्शनल ऑपरेटर है, ये इंडायरेक्शन देता है. सो 2 बार asterisk इसलिए यूज हुआ है कि उसे 2 बार इंडायरेक्शन देना होगा. फर्स्ट केस वाज कि कैरेक्टर कांस्टेंट है, सेकंड केस की पॉइंटर भी कांस्टेंट है. सो 2 बार इंडायरेक्शन आएगा, इसलिए 2 बार asterisk यूज हुआ है. Okay, pointers and functions. So the first case I did previously ho chuka, list of argument to the function in the normal fashion. So to pass the list pointer from the previous program to a function called print list, you can write print list pointer. Okay, inside the print list routine, the formal parameter must be declared like this. Okay, let's move to the program directly. Okay, so we have made a function here named test, and we have passed 2 arguments, int and pointer int. So what we are doing exactly? So we are setting the value of int pointer 200. Pointer 200. Okay. Now we are defining the main function, that is int main void. Okay, so void calling the function, or we can just directly do that. Nah. So int I, we will set int I to, they are setting 50, we are set 200. Let's take 200. And they are addressing this pointer to address node of I. Okay. Now what we need to do? They have not used, na? Or they have used? Mm. So before calling, okay, so they are uh, testing the output before calling. So print f, or you can just take the statement here from here, like this. So before the call to test I, so it will be 200. It will be 200. But when we call the function test here, and we'll pass this pointer 1, or this should be I, it's not 1. Pass the pointer here. Since this test function need a pointer here, we are giving in a pointer like p, and now we'll be printing the same statement here. Okay, this is the statement after the call. So it should be like 100 here and pointer 100, 200 and okay 300. It should be like 200 and 100. The output should be 200 and 100. Let's see. Hmm, 200 and 100. Because let's go to the program. Here we have not called the function, so directly the value of I is fetched here. But in this case, test p, the function is called, and we have passed the pointer of I, and the pointer of I is defined already here, that is 100, and 100 is what we are getting. Pretty basic question, not that much. Anything need to explain here? Pretty basic. So using pointer to exchange the values. Good example. Let's take this micro exchange dot c. So till here we are defining void exchange, and what we are doing, we are defining an integer pointer. Okay, so it is const. Okay, so const const we are using, so pointer is constant here, so p int 1, this pointer is constant here, and there is another argument that is again a constant pointer. uh, okay, p int 2, p int 2. Okay, so int third variable will be used to change the values. Okay, done. So temp1 firstly will be assigned to the pointer variable or pointer value of 1, then the p int 1 will be assigned to p int 2, p int 2. The same thing we have done to in the, I think this was covered in the exchange part in the functions, I guess. Part 9 was going on now. Part 5, it is covered in part 5 how we have done this. P int 2, and now p int 2 is temp, so pointer 2 is temp. Now we will write the main function. Int main void. So let's take int. They have taken how many they have taken? So we need I1, I2, and p int p, p1, p2. So p int 1, p int 2 we cannot take because it is already taken in the void exchange thing. So int I1 will be taken as 10. Let's take it 10. I2, let's take it to minus I2, let's take it minus 9, and let's take the pointer variable now to p1 is equals to 11, and let's take pointer 2 value as 12. Okay, not we don't need to take the value, no, we have to exchange. So for that we need and I1, we are assigning the values, so and I2. Pretty, it should be clear till here. Okay, taken the value. Now what we need to do, print firstly, because we have not called the function here, so I1 is equals to %i, I2 is equals to %i. So you should not be confused const char const pt as double pointer whereas char. You can say like this. Const char const pt is a double pointer, whereas const char const pt is constant pointer to constant character. Char const star. But before, this can be written, but what you have in the previous comment const char star const ptr, that was wrong, है ना? This syntax is correct, that char const star const ptr is const pointer to const variable. There's a difference between both, है ना? I cannot see the chats here, क्या? Nice. Let's leave this. So we are checking the values before exchanging. So I1, I2. My second system is switched off because battery is gone. I cannot read the comments na, for 5 minutes, next 5 minutes. So I1, I2 we have taken. Now we'll be calling the function, I guess. Yes, we are calling the function. And I have done one more mistake here. We'll pass the pointers p1 and p2 here. And this time the value will be changed. This will be taken. Okay, so control S Q GCC X exchange output exchange. I1 is 10, I2 is -9. But when we have used that function for swapping, I1 is -9 and I2 is 10. So the program is pretty much good. One change can be made. I can do like this to segregate. Okay, now it is pretty good. So this case is before swapping, this case is after calling the function, and swapping happens, exchanging of value happens. Can we end today's stream now? Pointer. Last topic is left now. Let's complete this also. Okay. So let's move to the next program. It's pretty much returning a pointer from a function. So where should we start from? So second call to exchange. Okay, let's clear this first. Nice. So program 11.10 shows how a function can return a pointer. This program defines a function called findEntry, whose purpose is to search through a linked list to find a specified value. When the specified value is found, the program returns a pointer to the entry in the list. If desired value is not found, the program returns the null pointer. Okay, good program. I think decision making will be there. Okay, decision making is there. No problem. So for linked list, we need to have a structure. So micro. Okay. So micro. Okay. What to name this program? Return. Dot C. Let's do this. Find. Have them named anything? findEntry. Let's do this. findEntry. Nice. My keyboard is too sensitive. I press one key, two keys are also pressed. Okay, so first we will be taking a structure. So struct entry, and yes, boom. Let's start this. So int value struct entry. Since it's a pointer now, next. Now what we will be doing, we need to find something till it is a null character or null. So not null character, null pointer. So struct entry. We need to find now. So let's take find as a pointer. Okay. Struct entry. Now the thing comes. So struct entry, find entry, struct entry again, then list ptr and patch. Okay, so we are defining a function find entry, which is a kind of a structure, and we are passing two arguments there. First one is a list, and second one is the match that we want. Okay, so function will be a pointer here, pretty obvious. Okay, so struct, we need a argument that is similar to struct entry, and the variable should be like list ptr, or let's take list here, and the second element should be an int that should match the value. Let's take match, and we need to define this function now. So while the list while the list is not equals to the null pointer, is not equals to the null pointer. So for that null pointer, struct entry 0. Electronic wizard, nice buddy, full support, thank you. So what we can do now, while loop in, while we don't need anything like colon, we need to make decision now. So if the list is equals to, or we need to check the value. So from list we want to extract the value, but list is a pointer, so we will do that same thing, pointer for pointer. Need to extract the value, and we are checking if it is equals to the match, it will be an integer, na? The value that is stored, it is an integer. So if it is matched, secure coding in C, yes, I will be making that soon. Secure coding in C. But next, after C programming, I will give few options. Uh, the highest vote on which I get, I will be resuming that. The favor in which most favoring option, my most favorite option is like beginning of the phase one of the penetration testing, that is information gathering, and we will be uh, gathering information using uh, we'll I will teach you about some of the digital forensic tools if you have ever heard about OSINT of open source intelligence. So the first option is that information gathering or the first phase of penetration testing. Both can be possible. Second option is assembly. Third option is secure coding, and fourth option is building exploits and malware in C. Many options exist. It depends on you. I will give you poll after completing this. Okay, so return to the list. Okay, else return to, not return na, we need to set something. So list will be set to the value, the next value, it will be set to the next node. So list is equals to list, and we will get the address of the next node like this. Mm, because since it is a structured entry and we need to return something, so after completing while, we can return our default, we can return to 0, or we can return to the uh, null pointer. Better to return to null pointer. Mm. Okay, let's create a main program here. Let's just finish this. Okay, so int main void. Now what we need? We need a list and we need a match. These three things are needed to us. So first we need the list. So for that, string entry n1, n2, n3. Okay, then what we are having, there are arguments that we have given. So struct entry list ptr is already known. List ptr we have not defined. So we need a list, and also we need to initiate the start of list. So list start, and it will be starting from n1. Now we'll be searching and search. And now we'll be entering the value. Still here we are working fine or not? Struct entry int value. Oh, okay, struct entry here, struct entry int value. Okay, we have defined a function find list int match, return to list. Okay, list is equals to list, next, returning to 0. Do we need to give the values from our own? Yes, we are giving the values. So let's do one thing. What values we are using? We are using the same values, no? Okay, so copy it, paste clipboard. Okay, so 100 200 calling the next function, no problem. n3 set to null pointer. Okay, now we need to print the values. Printf enter the value to find. We need user input now, so scanf and percent I search, so and search. Now what we need to do, so it is for searching, then we will call our that function. Now we will call that function and will be stored in this list ptr what they have used. Yeah, it is storing list ptr inside this find entry. Okay, so list, and we'll be showing storing find. First is the list, that is from where it is starting, list start. Then we need to pass the argument of match, that is search. Okay, it should be working. We need to store because we need to make a list, and we are starting from list start and going from search. And there's a case of null string, or sorry, null pointer. So if the list is why do we need list variable? In order to store the list here, we need to find this the value from a particular list in order to store something. Redundant, what is the meaning of this heavy English word? My English is not that good, brother. Please use easy to read. It is, I cannot read that. Not equals to the null character. Okay, now the use of list. You are asking now why we have used list. We need to print that we everything is stored in the list. We have stored everything by using this find function that we have defined upward, and we have stored everything inside this list, and we are accessing this list in order to get the value. Got it. Okay. Now we will be writing the else conditions similar. No, that much. Else printf not found. Pretty simple, not that much. Uh, let's see if there is any error. No errors. Control S, Control Q. So this is our last program for today's stream. Entry.c, and writing the output to find enter the value to find 330, not found. So the three values that we have stored is 100, 200 and 300. 100 found, 100 300, 200, oh sorry, 300 found, 400 not found. Okay, so it's working fine. So I have already explained the code while writing it. No need to explain it. So let me just uh, nice. Take this code one more time. Micro find entry.c. What we have done, similar, the case of struct that we want to structure a linked list, and here we have given the values. This is the null pointer, you can say. And here what we are, so this is the main concept of writing or finding the right what you can say, right value from the linked list. What you are doing inside this, we have defined a function which is pointer itself. Please show which are the different topics. What different topics you are talking about in this book? In this book, struct entry. Uh, like what are the next topics? Next topics are pointer arrays, uh, pointer characters, and constant characters with string with pointers, const characters, you can say. Operations on pointers. Next topics. Next topics na. Okay, after pointers, you are saying pointers and memory address. After pointers, we have hmm, after pointers we have operation on very easy, bitwise operator and left shift right shift. Not that much. Preprocessor, it is a very not that much needed in coding, but it's important. Preprocessors. More on data types, enumerated data type, type def, sign extension. Then working with larger program, it is like basically documenting your program, how you can document your program. Grep and said you should have a knowledge of Unix utilities. I have covered this in the Linux fundamentals, the previous series before C programming, the grep and set part. Input output operations, okay. File, okay, file handling, you can say file handling in C. Miscellaneous advanced feature, debugging program, object oriented programming, then summary and all. Not that much left. Okay, so that marks the end of today's stream. Uh, we will be having the stream tomorrow now, and it's a possibility if I have time we will be having two streams. Tomorrow is Sunday, I guess. Yes, Sunday. And 2 November. Okay, 2 November. Mm, okay, nothing that much important. Okay, let's see if we can have two streams tomorrow, and we need to cover pointers, and next topic is we have is bitwise. So there can be a possibility we have two streams, one in afternoon, one in the evening, or one stream in the evening around. Let's start the stream from 8 p.m., not 9 p.m. Okay, let's take 8 p.m. to 12 p.m. so we can complete pointers and that operators, bitwise operators. So bye bye, good night. That makes the end of the stream. We will not be continuing further, and please do come for the tomorrow's stream. Also, the I am repeating this thing again. The after completing the C programming, we have again left with I I have multiple options to start. I can start with assembly. I can start with secure coding in C and C++. But before starting for C and C++, you should have a knowledge of C++. I have to cover that also. And mm, secure coding, we cannot directly proceed. What we can directly proceed after C is that we can put a hold on the C programming and continue with assembly so that we can go for reverse engineering. And what else we can do is start the phase of penetration testing or real ethical hacking that we are insisting on, because C programming at the initial stages will not be needed at that much. But when you are talking about penetrating to advanced system and you want to exploit the system in order to get something, you need C programming at that time. So C programming will be needed after completing the final phase of the penetration testing, after 8 months of rigorous practice of penetration testing, solving all the machines, because all the machines can be solved on the pre software that is already existing in this world. But you don't need to make your own softwares for that, but or tools, you can say tools for that. So let's see what we can begin after completing the C programming. Okay, so Bash I have already covered, Bash programming I have already covered, and Linux I have already covered. So the stage is all set that we should be beginning with the phase one of penetration testing, or we can begin with assembly. Two options I can filter out. We have to stop. It's a bit disappointing that we have to stop C programming. I will be completing this till oops, till where it is mentioned. But after that, we cannot further, go for C++ then secure coding because it itself is a, lot different branch, and we as such do not need to go for reverse engineering and malware analysis or exploit development, because firstly we need to see how to exploit something. So what kind of servers are we penetrating? What kind of servers? Firstly, we should be penetrating the simple basic ports like SSH and telnets. That should be basic, not servers. Yeah, why do you need to target like NASA servers and all? Servers are basically Linux machines. So you can say we will be no learning to penetrate in Windows machine, not Mac. Mac is not covered, but Windows and Linux basically. Firstly, we need to go phase wise, na? We need to go phase wise. I've already covered this thing before. What are the phases of penetration testing? Let me show you that again. Wait a minute. I will show you that. Mm, Okay, I got it. Phases of penetration testing. This was the okay. So the pre-engagement, you should not be focusing on this because it is job oriented. So planning and reconnaissance. So I think I have given a chart or something like this. So first is footprinting or gaining the information, you can say. Then scanning, use of nmap and more tools. Then gaining access. Gaining access is something like if you kind of like some exploited some kind of port, you find an open port, how to exploit that service or something. Maintaining access, you can say backdooring. You have a backdoor in the system that you can just directly go. You don't need to do the stuff or hacking stuff again and again. And clearing the logs, like when you have hacked the system, you need to clear all the things that you have not visited the system ever. These are the phases of hacking: reconnaissance, discovery, exploitation, post exploitation, and cleanup. Okay, we will be going here one by one. Let's see what happens. So good night. Okay, let's meet tomorrow and we'll be having this